So you can imagine, even if someone's got a big component that's only got maybe a 15mm bore, 10mm bore that's deep, you can clamp on that bit of the bore using this system, and you can get some serious clamping force and access all sides of the outside of the component. Welcome to another Technical Corner. Today I'm here with David from Hainbuch, and we're talking about mandrel products and the huge mandrel range from Hainbuch. But first of all, there's a few misconceptions maybe still around about mandrel systems, how they work, how you hold on to components with them. What did mandrel technology look like before something like these products from Hainbuch came around, David?
Well, generally, mandrels were quite long. They tended to be made specific for a part. They had pretty low clamping forces, and they weren't really great.
So it sounds like these kind of mandrels were really the second choice. They were always the choice after you've tried to hold on the outside of a component and you just couldn't.
They kind of were, Rowan, because mandrels tended to be long. They were custom made, expensive. Now, what we're looking at here, 4 different types of mandrel, and they're all off the shelf items. All work very differently, but all off the shelf.
And these are completely changed compared to what people might have used a mandrel for in the past. How have they changed in general terms?
Well, one of the things you can see straight away is the shorter clamping lengths. These things, you look at them, you think the shorter clamping length, don't be fooled. These things are very powerful.
Absolutely. Because of that power, what does that mean you can hold with them? I mean, they don't look much to look at, but what could you put on the end of one of these pieces of work holding?
Well, the thing is with these is, these end stops have been pre-machined, but the minimum you can actually hold on is round about 3 to 4 mil.
Wow.
So with the end stops that you can see on each one of these mandrels, apart from the one at the end here, they have been machined back specifically, but we can start at a sort of 3 to 4 mil clamping length and go all the way back down to maybe 40 mil.
Yeah.
Now, don't think that, I'm not going to hold this part on 40 mil because these things have got a lot of power.
Yeah, so you've got much less chance of ripping something out the chuck than if you had with an older style mandrel that you might have had a bad experience with in the past. I guess that means people need to maybe start thinking about this as a first choice when they have a component. What should those components look like that they're then going to use this as a first choice rather than a second choice?
Well, you're looking at anything that's got a bore, particularly a pre-machined bore. So we're using that as the datum to hold it on the internal diameter.
Yep. And once you're holding on that pre-machined bore, what does the different styles of mandrel that you've brought in today allow you to do?
Well, if we can go through them individually, that might explain a few things. So what we've got here, this is a manual setup. You can put this on, a machining center, grinding machine, gear hobby machine, whatever you like, but it is a manually actuated version. Now this is our T211 mandrel. Now the beauty of this is it's a pullback mandrel, so you're pulling back via a draw bolt to an end stop. So you're holding axially and radially. And again, the clamping force in this is phenomenal. So a 211, generally heavier duty parts.
Yeah, absolutely. Like you say, you can put this on, it can either be a spun on a lathe or it can be used as a stationary piece of work holding.
Indeed. I mean, even with this setup here, we can actually unbolt this part from the red part upwards and mount that on the spindle of a lathe.
Yeah. So you get good repeatability and run out from the mandrel boss, but also the clamping forces from brand new technology. You can see the taper here that is being used to clamp the component.
Yeah. And, from a hydraulic cylinder, all the pressure is going into that taper. Obviously, manually, it's different because we're going to be using a torque wrench to tighten it up to the correct pressure.
And so if we move on to the next mandrel you've brought in, what kind of system is this?
Well, this, again, is a pullback mandrel, the same as the 211. This is a 212. But if you notice, this hasn't got a draw bolt on it. So ideal, really, for blind bores.
Yep. So we're talking similar kind of diameters, similar gripping length, similar
clamping pressures, yes, all that. And again, this can be mounted either manually or you can mount it hydraulically, either on a lathe or one of our Hydroc systems.
So you can imagine, even if someone's got a big component that's only got maybe a 15mm bore, 10mm bore that's deep, you can clamp on that bit of the bore using this system.
Yep.
And you can get some serious clamping force and access all sides of the outside of the component.
Well, that's the key. And this is what people don't realise. Holding internally gives you access to all the external components.
Yeah, absolutely. So maybe if someone's doing something in 3 or 4 different ops, if they've got a bore, they could maybe do that in the first op and then do everything else afterwards in the next op.
Yeah, absolutely, yeah.
Yeah, and that would save time with changeovers, maybe improve your precision as well. Let's move on to the next component you've brought in here.
Well, again, would you believe these two mandrels are identical in terms of their T212 mandrels, pullback mandrels, and again, no draw bolts, so blind bore. However, this is slightly different. This is what's called a MANDO adapt unit. Now, the MANDO adapt unit fits into one of our standard Hainbuch chucks. So if you've got that on a lathe, a grinding machine, gear cutting machine, you're able to change from collets to this in a matter of minutes. And if you notice around here, our 0-point unique system, so if the chuck's been set up correctly, it will follow that. So again, micron accuracy.
Absolutely, and that saves you some time if you're worrying about going from starting to use mandrel systems. You're worried about the larger changeover times, changing from a 3-jaw tuck to a completely different style. This eliminates that.
Well, you know where these have been the most popular? Twin spindle machine, 2 Hainbuch chucks, both spindle, and for op 20, let's say, the customer's probably decided that he's got to do some internal. He's done the internal bore, and now he's got to do the external components. So quick on with the MANDO adapt, 3 or 4 minutes, and then he's set up to do all the external stuff via ID clamping.
So what used to be potentially quite complicated sets of operations could actually be very quickly changed into a simple 2-op system, a 2-op process with a MANDO adapt.
Yeah, and one thing we've been proud of, and it's our modus operandi, is quick changeover.
Last but not least, this one looks a little bit different, but it's still a mandrel. What is it?
You're right, it does look quite unlike the 3 we've covered. However, that one and this one are very similar. However, that particular mandrel, the G211, the application really is for gear cutting, gear grinding, because it sits in the vertical position. You can have it horizontal. However, the gear companies seem to have took up on this one quite well.
Absolutely. So you've got the 3 faces here to change the end stop positions.
Indeed you have.
But what does that mean when you're trying to put different kind of components on? Why would you need these different faces?
Well, if you look at the bottom position there, Rowan, if you point to that, what we can do is we can put a bigger end stop on it, like a top hat to hold bigger diameter parts. So particularly gear blanks, similar to this, but a larger diameter, so we can sit it on top, because really you want to support as much of that as you can, particularly when you're gear cutting.
Yeah, is that because there's a lot of force in that gear cutting process?
Very much so.
And so being specified for gear cutting, where do you see these? What kind of machines do you see these applied to?
Well, generally gear cutting, gear grinding machines, we've got a lot of customers in that sphere who are using this mandrel.
Okay.
And they come in at, again, a family of sizes. And that's one thing we haven't actually touched on, that each of these mandrels comes in a family of sizes, because, if you look at this one here, that has a taper which the bush sits on. Now, we can go down to sort of 5.5 mil and then go up to 200 mil bush size. That's standard, off the shelf. We can go bigger as a special. But you can imagine that a 5.5 mil bush is not going to fit on there. Conversely, a 200 mil one's not either. So each mandrel has a range, and that applies to each one here. And the range is generally within about 30 mil.
Okay, cool. And that's 30 mil of different bushes to put on top of those tapers.
Correct.
What's the actual travel of those mandrels?
It's 1/4 mil. Not very much, but you see, this is where it gives us our clamping force. Now, these are all pullback mandrels. So you are clamping on the bore, so radially, and then axially, because it pulls back down onto the end stop. And that's with every single one of these here.
Perfect. So there's a lot you've shown us today, There's also another product that you've not brought, which is quite an impressive mandrel.
The MAXXOS.
Yeah. What would you like to tell us about
now,
that?
the MAXXOS works the same as each one of these mandrels, but it's a bit like our Top Plus system. So rather than having a round receiver, it's hexagonal. And the beauty of that is it gives you more rotational clamping force. And, you know, it's one of the most powerful mandrels on the market, if I'm honest.
Okay, and if someone's going to be reaching for a MAXXOS, why would they be reaching for it?
Gear skiving. You know, the forces that are exerted in gear skiving, you know, we would always specify something like a MAXXOS.
Perfect. Thank you very much, David.
Well, before we go, let me just show you, you know, the pullback effect with a gear. Now, obviously I'm doing it manually, but you can see how, you know, clamping this brings the bush up and pulls it back down, pulls the part down to the end stop. And that's basically, it's as easy as that.
So if someone thinks that this might be a good solution for them and they're having trouble holding a component, how can they get in touch?
Well, for a start, look on the website, give us a call, and then we'll come over and we'll find the best solution for you.